This video is going to focus on the other half of motion graphs, where we're going to talk about changing velocity, and we're going to include instantaneous velocity and acceleration. So we talked in the last video about the slope of the position time graph is velocity. When we have a slope that is in the upward direction in a straight line, that is an object that has a constant velocity and the slope is in the positive direction, so the velocity is in the positive direction. If the slope is downward, the object in the graph has a constant velocity in the negative direction because there is a negative slope. But when a line is curved, we are dealing with changing slopes. So in the first example, our slope is going to get steeper over time. It starts shallow or relatively flat, and the slope is going to get steeper. That means the slope or velocity is increasing. Now, because the displacement is increasing away from you, that also means it is positive. That is a positive velocity. In the second example, the slope is flattening out over time. So we start with a relatively steep slope, and we end up getting it flatter and flatter or approaching zero. So in this case, the velocity is getting smaller. It's slowing down, but the increased displacement still means that the object is moving away, or that we would have a positive velocity. For this example, the next example, we start with a relatively flat slope, and the slope is going to get larger and larger. And so this is a slope getting steeper. That means the velocity is increasing, the slope is increasing. It's just that it's increasing in the negative direction because the displacement is showing the object getting closer to you. So that is a negative velocity, but it is still speeding up. The last example, again, shows a relatively steep slope that is going to get shallower and shallower as it approaches zero. The slope flattens out with time. So the object's velocity is decreasing, it's getting slower, the velocity is approaching zero. Now the addition of the decreasing displacement means, again, the object is moving towards you, which is the negative direction. So here's a graph of an object sliding down a ramp and picking up speed as it goes. We can figure out how fast the object was going by calculating the slope. But in this case, because it's a curved line, we're going to get different answers depending on which instant in time we picked. That is what instantaneous velocity is. It's the velocity at a particular moment in time. So to find the instantaneous velocity, we need to draw a straight line tangent to the curved graph at the point we've selected. So in this case, we are looking at 3 seconds. And then we're going to calculate the slope of the tangent line. So here I have v sub 3. That's just saying that's my velocity at 3 seconds. So I pick 2 points, and I can calculate. And at t equals 3 seconds, my velocity is 6 meters per second. Now, the slope, if I take another point in time, so here we're looking at t equals 5 seconds. And so at v5, I can calculate a speed or velocity of 10 meters per second. So looking at the graph, you can see that the slope is increasing, but this now proves the slope is increasing, the velocity is increasing, so our object is speeding up in this example. So we can take all of these instantaneous velocities and we can generate a new type of graph. That is called a velocity time graph. Now, the graph I have here is not the one that would actually graph the instantaneous velocities from the prior example. But I could. You calculate several instantaneous velocities and you graph them to generate your velocity time graph. Now, with our new graph, our new velocity versus time graph, the slope is still our rise over run, but in this case, the rise is now going to be change in velocity, or delta v. So the slope is the change in velocity over the change in time. This concept is known as acceleration, or the rate and change of velocity over time. The slope, or the acceleration, can be positive or negative. A change in velocity can mean an object is speeding up or slowing down. But you have to be careful with those. Here's a warning. People mistakenly believe that a positive acceleration means the object is speeding up, and a negative acceleration means the object is slowing down. That is not necessarily true. Here's how it works. If the numerical values of an object's velocity and acceleration have the same sign, that's positive or negative, then the object is speeding up. So positive velocity, positive acceleration, speeding up. Negative velocity, negative acceleration, speeding up. If the velocity and acceleration have opposite signs, one positive, the other negative, then the object is slowing down. Positive velocity, negative acceleration is slowing down. So how to read velocity time motion graphs? If you look at this graph here, one of the first things you need to do is look at, is the velocity positive or negative? In this case, the velocity is above the zero line. Here's our zero line. Everything above this line is a positive velocity. It doesn't matter what this slope is doing. My velocity is positive because it's in the positive quadrant. If it's down below, then it's a negative velocity, regardless of what that line is doing. Now, the slope of the graph is also positive, so that means that we have a positive acceleration. We have a positive velocity, positive acceleration. That means this graph is speeding up. Another thing you can do to determine this is we are starting at a zero velocity and we are ending at a velocity that is above zero. So that is showing speeding up. Our velocity is getting bigger than zero. So the slope is moving away from zero velocity. That is speeding up. In this case, the line is in the negative section. So this is a negative velocity. The slope of this line is downward, so this is a negative slope, which means we have a negative acceleration. Velocity is negative, acceleration is negative. This again is speeding up. Notice it starts at a velocity of zero and it gets to a velocity that is not zero. The negative is just direction, so it's a velocity that is bigger than zero in the negative direction. So the slope is moving away from the zero velocity. This is speeding up. All right, this one, it's on the positive top part. So this is a positive velocity. The slope is negative, so the acceleration is negative. Positive velocity, negative slope, slowing down. Now this is starting at a velocity that is not zero and moving towards a velocity that is zero. The slope is moving towards zero velocity. It's slowing down. This one's in the negative, and so this is a negative velocity. The slope is going upward, so it's a positive slope or a positive acceleration. A negative velocity and a positive acceleration indicate slowing down. Again, going from a not zero velocity towards a zero velocity. That is slowing down. So quick summary, and I've included this in your notes. So one of the things that you may have to do is you have to be able to match a position time graph to the corresponding velocity time graph. There's a couple of ways to do this, but one of the best ways is to either write a written description of the motion demonstrated in the graph and match it to a verbal description of motion, or match the verbal descriptions of motions for two graphs, or looking at the velocity time graph, write out what it means and start sketching that as a position time graph. So here we have our velocity time graph. I just picked one of them. So the velocity is negative. So our velocity is negative. So if I want to make this into a position time graph, so here's my position, time. If my velocity is negative, that means that overall I have a slope that looks like this. So that's the first thing I need to do. I need to make sure to match it to a position time graph that has a downward slope. Now it says the acceleration is, well, it's going from 0 to a number that is bigger than 0. So I need to start with a slope to my line that is close to 0 and end with one that is bigger than 0. So to connect these, I start with close to 0 and end with something steeper. And this is what my position time graph should look like to match with this velocity time graph. So that's one strategy that you can use to try and match your graphs.